So, welcome everybody to this week's problem set number 3, which will deal with the topic of externalities. So, I guess until now you have seen some slides on this topic on the lecture, and it is basically the topic of actions done by um, participants of a market which have a direct consequence on the utility or the profit or any objective function of other parties in the market. Yeah, so this is the topic of externalities. And we will look at two different exercises on this topic within this problem set. So in exercise number 1, we have the following. Assume that the economy is composed by two firms, each operating on a competitive market. Firm A produces and sells steel. The production of a quantity YA of steel generates at the same time exactly YA units of pollution. The cost of firm A is given by a function CA depending on YA, where the marginal costs are strictly increasing. Yeah? So this is represented here by the derivative. And in addition, the cost function is strictly convex, which is described here with the second derivative being also strictly positive. Firm B is a fishery that suffers from the pollution generated by firm A, such that the cost of producing YB units of fish is represented by the function, so by the following cost function, which depends not only on the amount of fish which is produced, but also on the units of pollution, yeah, which is conducted by firm A. And we have some assumptions with respect to this cost function. So the marginal costs are positive, so the cost function is strictly increasing in the amount of fish, and it's also strictly convex. And in addition, the cost function is strictly increasing in the amount of pollution generated by firm A. Then we are giving two market prices, PA for fish and PA for steel and PB for fish. So question number 1 is the following. Is there an externality in this economy? Give its type and sign. Okay, so obviously there is an externality in this economy, and there is a direct negative externality. There is a direct negative externality. It is caused by the steel producer and it is imposed on the fishery. So in this economy, there is a direct negative externality, which is caused by the steel producer in forms of pollution, and it's impacting the fishery in a negative way. So how does this negative externality look like? So how does it manifest itself in our model? So it is basically given by the assumption that the cost function of the fishery is strictly increasing in the amount of pollution and hence in the amount of steel which is produced by firm A. So the negative externality reveals itself in that the costs of the fishery are strictly increasing in the amount oops, sorry, let me rewrite this. In the amount of steel produced. Oh, sorry. Steel produced. Oh, somehow my pen is not working properly today. 1 second. By firm or by the steel producer. Again, this finishes sub exercise A or 1, I think. Let me just check the numeration here. Yeah, so it's basically one exercise 1 sub exercise 1. Okay, this brings us to sub exercise 2, where we have the following. Find the first order conditions determining the quantity of steel and fish produced by the firms in a competitive equilibrium. What is the level of pollution at the competitive equilibrium allocation? So in this exercise, we basically assume that we have like the firms are competing in a non-cooperative way. So each firm is simply looking at its own objective function. So in this example, they're looking on their own profit functions and then maximizing according to this profit function with respect to their amount of steel or fish produced. Okay, so let us write down the optimization problems. So the optimization problems are given by the following. So the steel producer, firm A, is maximizing over the amount of steel which is produced, so YA. It's maximizing its profit, which is given by the price of steel times the amount of steel which is produced minus the costs of steel which is produced. So CA of YA. For the fish producer firm B, we have the following. So he's maximizing over YB. He's maximizing his profit, which is then simply PB times YB minus CB, so the cost function depending on pollution or the amount of steel produced and the amount of fish, which is, fished by firm B. Now we can derive the first order conditions. So first order conditions is simply shortcutted here. So we take the derivatives of the profit functions with respect to the endogenous variables, which is then for firm A, YA. And then we get the following condition, PA, so the marginal revenue of a unit of steel which is produced, minus the marginal costs for producing steel should be equal to 0. And if we get this, if we rearrange this, what we get is PA is equal to C prime A YA star. So the amount of steel which is produced is chosen in a way such that the marginal revenue is equal to the marginal costs. Okay, there is one more step that we can do. So we can do the step because the cost function CA is strictly convex, which means that the marginal cost function is also strictly increasing. Hence, we can inverse the cost function in order to get the following. Then we have YA star is equal to the inverse of the marginal cost function denoted by CA prime minus 1 applied on the price. Okay, and this is the amount of steel which is produced by firm A. So it's equal to the inverse of the marginal cost function applied on the competitive price of steel. This gives us kind of the correct or the exact amount in a explicit way. We get the exact amount of steel which is produced in addition to the amount of pollution which is kind of conducted by firm A. Now we can do the same exercise for firm B. So we take the derivative of the profit of firm B with respect to the amount of fish. Then we end up with basically an same condition, which is saying that the marginal revenue for firm B, which is the price of fish minus the marginal costs, so C prime B 2, and the 2 here, so let me just finish and then I will explain what the 2 means. So C B prime 2 YA YB, and the 2 here denotes the derivative of the cost function with respect to the second argument, because we're not taking the derivative of the cost function with respect to YA, but to YB here. This is why I write a 2 next to the B there. Okay, so just for you to know that this is just notation. So this should be equal to 0. And then if we rearrange this, we end up with the following condition. Marginal revenue should equal to marginal costs. There should be always some kind of this sign there to denote that it should be equal to this. So then we get the following CB 2 prime YA YB star. Okay, this is the kind of amount of fish which is fished by the fishery. Yes, and basically what you can already see here, if you just look on this condition here for the optimal amount of fish, is that if YA is increasing, so if Y is increasing, the marginal costs are increasing, and hence, in order for the equality here to be still fulfilled, we need to decrease the amount of fish. So basically what you can already see here is that the optimal amount of fish is strictly decreasing in the amount of pollution conducted by firm A. And this is somehow capturing the negative externality in an implicit way here. Okay, I think this was everything but with respect to exercise number or sub-exercise 2. So in exercise number 3, we are taking the role of a social planner, and we have to find the first order conditions which determine the socially optimal quantity of steel and fish. And then we compare the quantities that we find here in the social optimum with the ones that we found in the competitive equilibrium. And as we will see in the competitive equilibrium, so the quantities will be different, because in the competitive equilibrium, the steel producer does not internalize the negative externality that he is imposing on the fishery. And this is the reason why, from a socially optimal point of view, there will be too much pollution, and in turn, or there will the other way around, there will be too much steel produced and hence too much pollution from a social optimal point of view. But yeah, let's have a look. So this will be